today, which is a little bit more vocabulary stuff. And there is a Delta Math assignment for this that is also pretty difficult to photo math. And by difficult, I mean impossible. So you kind of have to just know it. So I'd pay attention. And I would write this down here. I would just write degree, name, and start getting them down. Or take a picture or something. Or this is being recorded, so if you just want to write it down later or look at it later, that's totally fine. I don't want to be on the slide for too long. So if you plan to write it down, maybe just leave some space, and I could flip back to it at the end, or we could watch a video, or you can snap a pic and write it down later. But from yesterday, the degree of a polynomial is just like the highest degree there is, the highest power there is in the whole polynomial. And if it's a degree 0, we call that a constant, right? Because that's I don't know, 3. 3 is a constant because we have this invisible x to the 0, right? Degree 0 there, right? And that's goes for any constant, right? I don't know, -7, right? Has that invisible x to the 0 because x to the 0 is 1, so -7 times 1 is just -7. So that's why it's degree 0. Degree 1 is called linear because we have lines. So when we think of something like y equals, I don't know, 2x minus 3, right? This was a line we could graph. And that's because we have x to the first, degree 1, right? And so that's why it's called linear. That's why it comes from lines. 2 is a quadratic. We've gone over that before, right? If we have y equals, x squared plus 4x minus 3. Remember, we factored these before. We split them up like this, right? This is a quadratic. We definitely used that terminology before. So because it has degree 2, right? 3 is cubic. That makes sense to us. You might have seen this before, right? That's a cubic, anything with x to the third, because it has power 3. Quartic is 4. Quintic is 5. In 6 or more, you just say the 6th, 7th, 8th degree, and so on. Okay. So, and then there's also standard form. And when you write a polynomial in standard form, all you do is write it in descending order, which is how we like to write it anyways. So when it says standard form, really it just means write it kind of how you should want to. Like if we've seen these before, right? We always want to put the biggest power first. So in this case, it's 4x to the 5th. And then the next biggest one is x squared, so minus that 5x squared. And then the next one is minus 3x, and then plus 9. So see how we take the highest degree, and then we just go downward, right? Degree 5, 2, 1, 0. So that's what I mean by descending order, and that would be standard form. Okay, if we did to this one, looks like x. Yeah, what's up, Sandra? Go back? Yeah, to this one? No problem. I'll give you a second. Okay. So, for example, this one here, again, the biggest one looks like x to the 5th. That's the biggest degree. So in standard form, we're going to put that one first. The next biggest one looks like x to the 4th, so minus 4x to the 4th. And then the next biggest one is x to the 3rd, so plus that 2x to the 3rd. The next biggest one is just that x. And then the last one is our constant term, which is that 1/10. So that would be in standard form. Again, just going in descending order, we have x to the 5th, x to the 4th, x to the 3rd, x, and then no x's. Right? That's what it means. That's standard form, and that's kind of just how we want to write it, right? Like whenever we did quadratics, we always wrote that x squared first. It just felt more comfortable to write that x squared first. right? It's kind of the same idea here, as long as you have multiple uh, powers. I'm going to leave that one up there for a second as well. Okay. So, some other things here. You probably want to write these down. I'll give you time to write these down. After you put it in standard form, so you'll notice this one's in standard form, x cubed, x squared, x constant, right? Um, there's a couple terms we need to know. The leading term, remember, a term is any amount of stuff multiplied together, so that's a term. And then plus or minus separates terms. So that's a term, that's a term, that's a term, right? So 4 terms. And so the leading term, the one in front, is literally just going to be the whole term in front. The leading coefficient, remember what coefficient means? Coefficient means like the thing that's multiplied to the variable. So the leading coefficient here is just 4, right? So the leading coefficient is 4. The leading term is 4x cubed, right? Because that's just what's multiplied to this variable here. The greatest degree, if you put it in standard form, should be the one in front. This has degree 3 because it's to the third. And then your constant is the thing that doesn't have any variables to it. It's just a number, which in this case is 7. I'll leave that up there for a second. I wouldn't worry about any of this stuff up here. I would just write this. Okay. So rewrite the following polynomial in standard form. This one is already in standard form, right? It has x and the constant. Name the polynomial and determine the number of terms. So this is a linear polynomial because it's degree 1, right? That's to the invisible first. So it's linear. There's 2 terms. Remember I said terms are broken up by addition and subtraction, 1, 2. The constant term is -5, right? Just the number. And the leading coefficient is an invisible -1. What's multiplied to that x? So that's the leading coefficient. And I don't want to spend too much time on this one. I want to make sure we can get to some other ones. So I'm going to keep going maybe to this one. So rewrite it in standard form. So x to the 4th is highest, so I'm going to write that 4x to the 4th here. The next highest is x squared, so that -5x squared, then -3x plus 9 in that descending order. And now it wants all this stuff, so name the polynomial. This is going to be, it's to the fourth. So if we remember from our beginning one, that to the fourth is a quartic. Right? The number of terms is 1, 2, 3, 4, split up by the minus and pluses. So 4 terms. The constant term is 9, right? That's the constant term, 9, because it has no variables to it. The leading term, the whole term is 4x to the fourth. Right? That's the whole term. And the leading coefficient is just then 4. Right? Because that's the one in front. I'm going to see with ones like this, I'm going to see a bunch of -5 and -5x squared for the leading. But remember, you have to put it in standard form first. So make sure we put it in standard form first. I'll leave that one up there for a little bit. Okay. This one, again, standard form first. This x to the fifth actually looks like it's the highest. Then we have that 4x to the fourth, that 2x to the third, that minus x, and that minus 1/10. This is to the degree 5, right? It has degree 5. That's the highest one, so it's a quintic. Right? How many terms are there? 1, 2, 3, 4, 5 terms. The constant term at the end is -1/10. The leading term is the whole term, -3x to the fifth, and the leading coefficient is just what's multiplied by the variable, or -3.